Hello and welcome everyone. Our today's question is Toeplitz matrix. Correct me if I am wrong. So in this question, we have to check whether all the diagonal values are same or not. So in this example, the diagonal values are 6, so it is same. For 7 it is same, 8 it is same, 4 it is same, and 1 it is same. If all values are same, we have to return true, otherwise false. So let's jump into the approach. So we have this matrix size n cross m. This question requires diagonal traversal. So first we have to traverse in this manner, then in this manner, then this and these values. If you know diagonal traversal, it is easy for you. So let's jump into the approach. For diagonal traversal, we have a diagonal d 0. So for these values, first diagonal traversal, simple diagonal traversal I am telling you. So for simple, we traverse in this manner. So first 5, then 6, then 9. So for simple diagonal traversal, our first index is 0. So we are starting from 0. So as you can see, its value is 0, 0, and then 0, 1, then 0, 2. So its difference is 0, its difference is 1, and its difference is 2. N in this case is 4, and M is 3. So we have to traverse till M. So we will traverse till M. So M 0 till M. So in this we have one loop. So starting from 0, as you can see, our jth value is changing according to D. So our j value depends on D, and our I value is same 0. So I value is 0. So first case we have D0, so our I and j value is 0. So 0, 0. Then we will move to next diagonal value. So its value is 1, 1, and its value is 2, 2. So I and j is incrementing every point. So I plus plus and j plus plus. And what's the condition here? So condition is I, suppose we are here I 1, 1 and 2, 2. So after that we have 3, 3. But this index is not valid. How we find that? So I must be less than equal to n, and j must be less than equal to m. So it must be under the range of n and m. So this condition we have to fulfill. So we will fill the condition here. I less than n and j less than m. Let's dry run this approach. So first we have d is equal to 0. So d 0, then I 0 and j 0. So after that we have 1, 1 and then 2, 2. So we find these values. So these all values are equal. And after that d value increments. So I is 0 and j value depend on d. Now d is 1. So 0, 1. So we are at this value. Then after this value we have 1, 2. So 1, 2. So all values are same. And next d increments I0 and j value depends on d. So 2. So I2. Then we have 1 and 3. So it is not under the range. So these values. So we have traverse 5, 6 and 9. Now it's time for other diagonal. So we have to think a little bit. So here we have index 1, 0, and here 2, 0, and here 3, 0. Let's start from here 3, 0. So we are starting from the last value of I. We are starting the last value of I. So d value starts from n minus 1. N in this case is 4. So we are starting from 3. 3 is the row number. So row number, and it will go till 0. So this value, this value and this value. I am going in this manner. So its value is I. So I depends on D. So first I is 3, n minus 1, and in this case 4. So 4 minus 1 is 3. So first I is 3, then I is 2, then I is 1, then I is 0. So I value depends on D. And J value, if you observe, J value is 0, 0, 0 and 0 here. And condition is same, I must be less than n and J must be less than m. And we have to increment our I and J pointers. So let's start. So first we have I depends on D. D value is n minus 1. N is 4 and n minus 1 is 3. So I is 3 and J is 0. So 3 0 this value. Then it will go to next value. So which is 4 1. 4 1 is out of bound. So we have checked this value. Now D value changes. D value decrement. So first D value is 3. Now D value becomes 2. So I 2 and J 0. So 2 0 this value, and now it will increment. So I 3 and J 1. So I 3 and J 1, we have checked this value. Now it will go to next value 1. So now 1 0 1 0, then this value 2 1. So 2 1, then this index 3 2. So 3 2. So now 0 0. But if you observe, we have already checked the 0. So we are not required to go till 0. So 0 we can avoid because we have already checked for 0. So 0 excluding. So we can write it like this, I. So D here is n minus 1 and D is greater than 0, not equal to greater than 0. So we have solved this. So if we go inside this loop, so how to check if all elements are same? So we will take a variable. I am taking E. I am setting E value as minus 1 because the constraint is given that all the values are positive. So I am taking E is equal to minus 1. If E is minus 1, means I have not taken any element. So I will take the current element ith and jth element. If I have taken an element, so it will go to else block and I will check if E value is not equal to the current element. If E value is not equal to the current element I and j, means the diagonal elements are not same. So we will return false. So false we have checked. So here also false will be checked, and if all values are same, the code will go to the end and it will return true. So let's jump into the code. So first find n and m. Now first this is the basic diagonal traversal. So d is equal to 0 till m. Then we have e. So we have not taken any element. So we have I starting value 0 and j is equal to d. So j depends on d. So you can assume it like we are taking the 0th row. So the condition must be satisfied. The indexes must be valid. So increment our indexes. If we have not taken any element, so element is equal to minus 1, then take the ith element. And if we have taken the element, just check if element is equal. If it is not equal, return false. Now go to the other diagonal. So we are traversing from bottom. So you can assume it like 0th column. So I depends and element is equal to minus 1 and I depends on d and j is equal to 0 because 0th column. So I must be and j must be a valid index. So increment our indexes. If we have not taken element, if we have taken element and elements not same, return false and else return true. So this solution will work fine. If you are watching till now, consider subscribing this channel. It will motivate me to continue this series, and thank you all for watching this video.